So this is essentials from April. 125 years of Kodaikanal Solar Observatory. 125 years. Madras Observatory was merged with Kosovo following the reorganization of all Indian observatories. Reorganization of observatories. तो ये किसके टाइम पे हुआ था? That's how we do history. Reorganization of observatories. All observatories in India. Okay, so ये this picture is Kodaikanal Solar Observatory. Since ancient times, seafarers, mathematicians, astronomers, and physicists have all extensively studied and followed the sun and its activities. In 1792, the British East India Company established Madras Observatory, a first of its kind in this part of the world. 1792, Madras Observatory. 1792. Okay. So 1792 में मद्रास ऑब्जर्वेटरी बना था. Then next क्या हुआ? Next thing in the sequence, 1899 में सारे observatories reorganize किए गए. Reorganization of all Indian observatories. Alright. Here, astronomical observations of the sun, moon, bright stars, planets recorded during 1812 to 1825 were preserved in two large volumes, data volumes. The first dedicated solar observations were recorded in 1878. Ooh, so basically, this is the first dedicated solar observation, 1878, and right now this year we are going to send our mission to the sun. The name of it, Aditya L-1. So this is going to be very important, and उसके introduction में we can use stuff from this कि सबसे पहला solar observation 1878 के record में मिला. First solar observation. Back then, astronomy was largely limited to special events like eclipses or planetary transits that drew huge interest from foreign astronomers to visit India. Some of these visitors later settled here and laid a foundation for observatory based astronomy in the country. So, particularly, India was always attractive place for space research. But why? Astronomy was largely limited to special events like eclipses or planetary transits. ये है कोडाईकनाल सोलर ऑब्जर्वेटरी back in the day, and several important observations were made here. The spectroscopic observations taken during the August 1868 total solar eclipse from Guntur in Andhra led to the discovery of helium, the universe's second most abundant element after hydrogen. Second most abundant after hydrogen. So basically, and for the first time, celestial solar photography were attempted from Madras Observatory during the total annual solar eclipse in 1871. And even in those times, India made a landmark discovery. Links to the Great Drought. Scanty rainfall over South India during winter monsoon in 1875 triggered one of the worst droughts. We have already been asked questions on droughts, failed crops over the famine-stricken peninsular India killed 30 million people across Madras and Mysore provinces during 1875 to 77. This has to find a mention in every answer on Indian history of droughts during British times. 1875. So India, along with China, Egypt, Morocco, Ethiopia, Southern Africa, Brazil, Colombia, Venezuela suffered concurrent multi-year droughts during 1876, 1878. So later named the Great Drought. Ooh. And an associated global famine that killed nearly 50 million people. So drought, you say, is explicitly mentioned that it's followed by a famine, followed by famine, the Great Drought. I'm definitely going to use this somewhere in some paper of mine. The Great Drought of 1875. India was also affected. 30 million people died in India. So majorly, perhaps, it was Indian population that was the worst affected. So the drought was thought to be, ये हम लोग यहाँ पे भी देख सकते हैं कि एल नीनो का इफेक्ट कौन कौन से कंट्री में पड़ता है, वही है क्या ये सब करके. सो इंडिया एंड इथियोपिया टू बी नोटेड बिकॉज अफ्रीकन ईस्ट को वो करता है. ब्राज़ील, कोलंबिया एंड वेनेजुएला एंड चाइना. So we'll think about this. The drought was thought to be due to multiple reasons. Solar activity, cool Pacific Ocean conditions followed by a record-breaking El Nino in 1877-78, a strong Indian Ocean dipole, and a warm North Atlantic Ocean condition. So ये हमेशा जनरली दुनिया के साथ हमारे मानसून का रिलेशन पूछा जाता है, ये effect on Indian climate because of things happening in some other part of the world. Why study the sun? Being the primary source of energy, life on Earth is supported by sun. Any change on the solar surface or its periphery could significantly affect the Earth's atmosphere. Powerful solar storms and solar flares can potentially be harmful to Earth's satellite based operations. Okay. Economic, जब तक फैक्टर अपन गिनाते नहीं ऐसा लगता है कि कुछ गिनाया नहीं है. Power grids, right? Navigational networks. COSO, the Kodaikanal Solar Observatory, which has been imaging the sun for over a century now, has a rich repository of data. This is extremely useful not only to reconstruct sun's historic past, but also to link its behavioral changes to better understand and predict its future and its impact on life on Earth and space weather. Solar Physics Observatory in Palani Hills. Palani Hills, पता है ये ईस्टर्न घाट्स में ही है तमिलनाडु में. Based on the evidence that solar activity was linked to the seasonal rainfall distribution over India, the specially constituted Famine Commission of British Raj recommended that the government of India take regular solar observations. Recommended the government of India to do this. Based on the evidence, the solar activity was linked to seasonal rainfall distribution over India. This is gonna be an important line. So Indian Solar Observatory was always an idea for India. The Scotland-born Charles Mackey Smith, a professor of physics at the Madras Christian College, was entrusted to locate an ideal site for setting up this solar observatory in undivided India. Hills of Leh, Mussoorie, Shimla were rejected for being dusty and cloudy, and the atmosphere around them being unstable in Himalayas. Okay. Smith then conducted regular astronomical observations on southern India's hilltops, which were found to be better. Later, Smith surveyed hill stations located over 2000 meters above the mean sea level in Tamil Nadu Kodaikanal, 2000 meters, in the Palani Hills, and Kotagiri in Nilgiris. In the survey of rainfall, cloud cover, and sky transparency, haze, atmospheric stability, humidity, fog, and mist was completed, and Kodaikanal was chosen as the ideal location for the observatory. In August 1893, the government of India sanctioned a solar physics observatory under the meteorological budget. And Lord, whatever, the then governor of Madras, laid its foundation stone, supervised by Smith, who went on to become the first director of COSO. Ongoing civil construction took place by 1900s. The main observatory building and the two adjacent domes were built and ready to accommodate instruments. So mainly Governor of Madras has been playing the role. Okay. The Madras Observatory, where Smith briefly served as a government astronomer, was merged with COSO. Madras Observatory was merged with COSO. And following the reorganization of all Indian astronomical observatories implemented by Government of India in 1899, instruments mainly from the Madras Observatory supplemented the new ones at COSO, where systematic observations commenced, and Bhavnagar telescope, named after Maharaja of Bhavnagar, operated during COSO's Nazana. Where is Bhavnagar? Is it in Gujarat? Operated during the COSO's nascent years. Bhavnagar telescope, ये भी एक important नाम है. The 16-inch Newtonian, later Cassegrain, I don't know how it's pronounced, mobile telescope remained India's largest from 1888 to 1968. Oh, Bhavnagar telescope. Okay, so it was imported from Dublin, Ireland, and was first established at the Maharaja Takhta Singh Ji Observatory in Pune. Now Pune, around Pune, 1888. However, the Pune Observatory closed down and the telescope was sent to COSO in 1912. Some of the, alright, ये history हमें जानने की ज़रूरत I don't think we have, but there's something called Bhavnagar telescope which was huge for a long period in our modern history. However, the Pune observatory closed down and the telescope was sent. Okay. Some of the early solar observations at COSO included the examination of the sun's disk from spots and faculae, tracing bright lines from the sun's chromospheres, prominences, visual and photographic observations of bright lines widened at the spectra of sunspots. Oh, okay. Sunspots. Measuring solar radiations on clear sky days and the direct photography of the sun in monochromatic lights of calcium and hydrogen. So calcium ऐसे भी use होता है वैसे इसीलिए X-ray इतना अच्छे से हो पाता है वैसे. The radial motion of sunspots, better known as the Evershed effect. The radial motion of the sunspots, Evershed effect, was discovered from the sunspot observations made at COSO. Okay, sunspots. So this discovery was also made in COSO, and the radial motion, इसमें से आपको थोड़ा सा भी मतलब मुझे थोड़ा सा भी अगर याद रहेगा इस हिस्ट्री के बारे में, तो अगर मौका मिलेगा तो मैं उसमें से एटलीस्ट एक ब्राउनी पॉइंट तो ले सकता हूँ. एक पॉइंट तो अच्छा सा मार सकता हूँ जिसके एक दो नंबर मिल सकते हैं. इनफैक्ट उससे ज़्यादा भी इफेक्ट हो सकता है. तो was discovered from the observations made by made at COSO by John Evershed, COSO director. All right. And until the end of World War II in 1945, COSO remained an observatory dedicated to solar physics. Thereafter, it expanded its ambit to study cosmic rays. Alright, now cosmic rays. radio astronomy, ionospheric physics, stellar physics. The continuous recording of the solar radio noise flux commenced in 1952 is considered the earliest solar radio observatories in the country. Contemporaries Maharaja Takht Singh Ji Observatory, Lucknow Observatory, and Calcutta Observatory did not stand the test of time. So और भी थे लखनऊ ऑब्जर्वेटरी, ये भी नाम बताएंगे? कैलकटा ऑब्जर्वेटरी और महाराजा तख्त सिंह जी ऑब्जर्वेटरी और अपना भावनगर टेलीस्कोप, ये सब are the names. Uh, if we ever get a chance to mention uh, scientific advancements during British era, maybe Bhavnagar telescope and Madras astronomy, Madras Observatory and COSO, Kodaikanal Solar Observatory. Kodaikanal at 125, the government of India separated. So 125 years हुए हैं इसके, इसलिए ये न्यूज़ में है इसके साथ. सो वी गेट द नंबर 1899. तो 1899 में ही रीऑर्गेनाइजेशन एक्ट भी हुआ था, तो इसके साथ विल रिमेंबर reorganization of observatories. The government of India separated astrophysics from the India Meteorological Department (IMD) in April 1971. The COSO was brought under the Indian Institute of Astrophysics (IIA) Bengaluru on April 1, 1971. From solar data recorded on basic photographic plates or films, the 125-year-old COSO boasts a mammoth digital repository containing 1.48 lakh digitized solar images of 10 terabytes. This includes 33,500 white light images showing sunspots and thousands of other images of the sun recorded every day. Since the start of the 20th century, COSO is the only observatory offering high resolution digitized images for such a long period with coverage of more than 70%. So, only observatory offering such high resolution digitized images for such a long period. COSO data बहुत है COSO के पास, high quality data. And COSO a spectrum of advanced instruments like the H alpha telescope to perform full disk imaging. We'll just write this down, but ये याद रखना ये सब देखते हैं अगर इसका, आई डोंट थिंक, मतलब ऐसे सोचते सोचते कुछ चीज़ें याद रह जाती हैं. दैट्स द प्रोसेस. So H alpha telescope to perform full disk imaging, a white light active region monitor warm with calcium. Calcium is also used in astronomy, okay, because X-ray पास नहीं होता इसीलिए calcium X-ray में दिख जाता है. So calcium filter, sodium filter to make full disks of simultaneous observations of the photosphere and chromosphere layers of the sun, a solar tunnel telescope, and more. So basically, there's a high probability of a question from Aditya L-1, and ये तो कोसो के बारे में नहीं पूछेंगे, बट इन दी हिस्ट्री ऑफ आदित्य एल वन के बारे में अगर 15 मार्क का या 10 मार्क का लिखने, जैसे लास्ट ईयर चंद्रयान के बारे में दे दिया था, तो इंडिया हिस्ट्री ऑफ सोलर एस्ट्रोनॉमिकल ऑब्जर्वेशंस दे दिया अगर क्वेश्चन, आदित्य एल वन को रिलेट करते हुए कुछ ऐसा क्वेश्चन कि हिस्ट्री में भी हमने काफ़ी कुछ किया है, डिड यू नो? तो उसके बारे में अगर लिखना है तो ये डेफिनेट बेस्ट मटेरियल है, ऐप मटेरियल है. और इसमें से लेकिन आई ड्रॉ सम स्टेटमेंट्स जिससे मैं कोई इंट्रोडक्शन पॉइंट या कंक्लूजन आदित्य एल-1 के बारे में कुछ भी पूछे तो बना पाऊँ, ये करना है मुझे. तो आदित्य एल-1 के बारे में जो भी पूछ रहा है उसके लिए मैं यहाँ पे अपने आर्टिकल से कुछ स्टेटमेंट्स ड्रॉ करके लिखने वाला हूँ. So this is in concise the data that we are going to use. 1792 में मद्रास ऑब्जर्वेटरी बना था. 1868 में टोटल सोलर एक्लिप्स के ऑब्जर्वेशंस में हीलियम की डिस्कवरी हुई थी. 1899 में रीऑर्गेनाइजेशन ऑफ ऑल इंडियन ऑब्जर्वेटरीज एक्ट हुआ था, तभी कोडाईकनाल सोलर ऑब्जर्वेटरी बना था इन परानी हिल्स. और एक चीज़ है भावनगर टेलीस्कोप, विच हैज़ बीन द लार्जेस्ट टेलीस्कोप इन इंडिया फॉर more than 50 years pre-British time का था. So this is what we are going to use somehow in this answer. Exactly, we don't have the question to answer. So India has always been an attractive destination for astronomical research, and there have been solar observations and observatories and data in India from British times. So there's a legacy of Indian solar research.